Hello and welcome to this video about the failure and analysis of asynchronous motors. Asynchronous motors are the most common type of motor used. They are known for their advantages such as low purchase price, high efficiency, easy regulation, and simple but robust construction. Despite their high reliability, asynchronous motors suffer from some malfunctions of machine parts. We can divide failures in an asynchronous motor into failures of mechanical and electrical origin, as well as stator, rotor and bearing failures. Let's start with the bearings. All parts of the bearing are subject to degradation. The cause of bearing failures can be considered as mechanical stress during rotational movement and bearing currents. Mechanical stress can be caused by poor installation, poor assembling, or by improper use, overloading, and poor maintenance. The bearing currents can be caused by shaft voltages due to asymmetric electrical circuits or power supplies, and capacitive currents caused by the pulse frequency from the power supply control of semiconductor converters. All mechanical and some electrical motor faults have a unique signature in the vibration spectrum of the machine, and vibration analysis can recognize them. Failures such as misalignment, looseness, unbalance, and bearing faults are diagnosed according to the same rules applicable for all other machinery parts. How do we analyze mechanical faults? Get the answer, for example, from our video named How to Become an Expert in Vibration Analysis and our other tutorial videos. What is vibration analysis? Our series of vibration analysis for beginners videos will help you to understand this topic. Some electrical faults are recognizable in the vibration spectrum too. You should measure the motor with and without a power supply in order to find them. Some vibration signatures could disappear after power off, those with an electrical origin. You can also focus on the exact frequency of peaks in the spectrum. If you find a peak with your exact current supply frequency, for example 50 Hz and more often on its harmonic frequencies, it is probably an electrical issue, because there is always some slip on a loaded electric motor, and the motor isn't running on its exact rotation frequency. Electrical and some mechanical motor faults have a unique signature in the frequency spectrum of the motor current. The MCSA method can recognize them. MCSA stands for Motor Current Signature Analysis. Excessive sidebands are created in electric motors which distort the frequency spectrum. Each fault then has its specific signature. Individual defects can be distinguished from each other according to the amplitude bands and the frequency or other signatures. The basis of this method is to measure the course of the stator current of one or more phases in the time domain and its subsequent spectral analysis. Stator faults. Stator winding faults cause the majority of problems in stators. Broken winding insulation is the most common stator fault. MCSA can recognize broken insulation between threads, which can lead to broken insulation between phases, and it is fatal for the motor. Thermal stress has the greatest impact on the life and quality of insulation. Another undesirable effect is the electrical stress of the transient voltage. In the case of more and more frequent use of inverters for soft start, rectangular voltage pulses are modulated at the output of the inverter. Rotor faults. The rotor of an asynchronous motor consists of a shaft, insulated sheets pressed on the shaft which form the rotor magnetic circuit, and windings. Mostly the winding of the rotor consists of a cage structure, which is formed by bars, which are connected at the ends. Rotor eccentricity, meaning the unevenness of the air gap between the rotor and the stator, and rotor bar interruption are the most common faults. The cause of these faults can be the use of poor quality materials, overloading or heavy starts. In the case of rotor bars, the fault may increase the resistance of the bar or completely break the bar electrical circuit. Rotor bar failures result mainly in engine starting deterioration and generating parasitic moments. Also, the broken bar causes additional faults in other bars because the current in them is greater due to the missing bar current path where one bar is broken. The VA5PRO vibration analyzer offers the unique capability of analyzing vibration and current in one device. In addition, the MCSA module expands the capabilities of the analyzer and allows you to do analysis of the current signature from the spectrum based on your knowledge and experience, or you can use the automatic detection function. It is a similar feature to the Automatic Fault Source Identification tool, FACIT, for vibration analysis. The device can automatically recognize the main causes of failures such as unbalance, looseness, misalignment, and bearing faults. The MCSA module of the VA5PRO device is able to automatically identify rotor and stator faults, eccentricity, broken rotor bars, and power quality.